Good evening to all. My name is L. Kirtana. I am from EC department. Today I am here to give gra- a Huffman coding in digital image processing. Let us know the what is mean by Huffman coding and how it is used and why this coding is used. Basic introduction of the Huffman coding is a popular technique for compressing data. By this, we came to know that Huffman coding is used for compressing data. Compressing data means we are reducing the size of the data. It assigns, Huffman coding assigns shorter code for more frequently occurring characters. When the character is occurring more frequently means then it assigns shorter code and it assigns longer code for the less frequently occurring characters. This is the main advantage of this coding. And how the Huffman coding works. At first, we are calculating the character frequencies. Means we are calculating which character comes how many times. It comes whether one time, two time, or three times. It means only the calculating the character frequencies. And after the calculating character frequencies, we are building a Huffman tree. Huffman tree is built by create a node for each character and its frequency. We are creating a node for each character and its frequency also. And it repeatedly combines the two nodes with the lowest frequencies. Means it combines the two nodes which are with the lowest frequencies into the new node, and uh, it will be compared with the other nodes whether it is greater than the below node or less than the below node. If it is less than the below node, it is kept at the last only, and if it is greater than the below node means it is kept upside than one. And we are generating the Huffman codes. How we are generating means transfers the Huffman tree to generate code for each character, and we are repeating this process, which process means Huffman tree process is used and we are generating the code. The basic formula used in Huffman coding is H is equals to sigma H is equals to sigma I is equals to 1 to s p of I log 2 1 by p of I, where p of I means the frequency how many times it occurs, and it denotes the p of I is the probability, and it denotes that one. We are calculating the Huffman coding through this formula only. Then this is the basic formula we are using. H is equals to sigma I is equals to 1 to s probability log to 1 by p by 1. H is the replace the entropy of the Huffman coding. It denotes the entropy of the Huffman coding. The efficiency of Huffman code. N is equals to H by L average. Well, L average is the length. L average is the length. H is the entropy, which we are denoted. And we know the formula also. The compression ratio is C is equals to N1 by N2, where N is the Huffman coding efficiency. Then we are compressing 2 means efficiency of first one by divided by efficiency of second one. This is the basic compression ratio used in Huffman coding. The relative data redundancy, which is denoted by the RD, and the formula of this one is 1 minus 1 by C. 1 minus 1 by C, where C represents the compression ratio of the two codes. 1 minus 1 by C. These are the basic. Let us know the example for the Huffman coding. here the given probabilities are 0.1, 0.5, 0.15, 0.2, 0.05, 0.15, 0.3 and 0.1. We are assigning the respective variables for this respective probabilities as x1 for 0.05, x2, x3, x4, x4, xy, x6, x7. And here we are writing the messages and the respective probability in decreasing order. The first highest probability is 0.3, which is respective variable is x6. So we are writing in the highest priority. The second one is 0.2, which is x3. And third one is 0.15, which are both x2 and xy. So we are writing in the continuous order like this. And the next one is the 0.1, which is the x7. And the x1, x7 or x1 and x4 are the probabilities having 0.15, which is in lowest order. So we are writing in the continuous order like this. Here the probabilities are in decreasing order. So according to the Huffman coding, we need to add the last two and adding the last two one, and the sum is the sum is written to the next one. The sum is written to the first reduction at 0.05 plus 0.05 gives rise to 0.1. Both gives rise to 0.1, and the same probabilities are written according to the decreasing order only. According to the decreasing order only. Next one. After this first reduction, then the first reduction table is also written here, which are also in the decreasing order only, but the frequency get reduced. Uh, and here the last two are added at 0.10 plus 0.10 gives rise to 0.2. By comparing the other ones, we need to this sum is gives rise to 0.2, which is the greater than 0.15, 0.15. So we are writing this sum in the up one by comparing these frequencies. By comparing these frequencies, we are writing the respective this is sum. The sum in other one. After this, we are after the first reduction, then we are adding the both one at 0.15 plus 0.15 gives rise to 0.3, which is above than the 0.2. So we are writing this one in the upside and the same 0.2 code in the down. Next one is the next adding the last two frequencies 0.3. By adding these two we'll get the sum as 0.3, which is greater than the 0.2, 0.2, and it is same frequency as the 0.3. So we are writing these two on the upside and these two as the downside. After this, we are adding the last two frequencies in the third reduction also, which are 0.2 and 0.2. As 0.2 plus 0.2 gives rise to 0.4, which is which this probability is greater than 0.3. So we need to write this probability at the first, and we need to write this one as the last one. After this, the 0.4 is come to the up position and the 0.3, 0.3 are in the down position. We need to add the last two frequencies, this one. After adding these two frequencies, we get the sum as 0.6, which is greater than the 0.4. So we need to write this one at the upside and the 0.4 as the downside. This is the last reduction and we get the total sum 0.6 plus 0.4 gives rise to 1, which is the very correct positions, and it is one of the correct one. If we get the sum as 0.4 not means the problem we done it is wrong. This is the basic assumption problem. If we get at last reduction, if we get the sum as 1 means it is we done the problem in the correct order. Okay, next we need to know the next we need to assign the code words. Code words, but we need to add the code words from the last onwards. Let us know. Let us explain. We need to add from this one onwards. We need to assign 0 for one and 1 for this one. After assigning like this, we need to compare where this code is coming. As we know that 0.6 is come from 0.3 plus 0.3. So here the code word is 0. So we need to keep 0 0, and 0.4 is come from 1. So here the code word is 1. So we are keeping this 1 as here. After this, as the 0.6 is come from 0.3 and 0.3, we need to assign here 0 and 1 as the same code. Then 0.3 is come from here. The basic code include is here is 0 and 0 0, and here is 0 and 1. After we need to add this one like this, and 0.4 is come from 0.2 plus 0.2. So we need to add 1 1 and assign here 0 and 1 as the code word. The 0.3 is come from here. The basic code word include is 0 and 1. So here we are assigning 0 and 1. And the 0.2 is come from here. The basic code word is 0 1 0, and we are assigning here this one. And the 0.2 code is 1 1. So we are keeping the same here also. And here we are using 0.3 is the sum of the 0.5 1.0.15. So here the code is 0 0. So we are assigning here 0 0 0 0 as the same code, and we are assigning also 0 and 1 for this one because the sum is done here. After that, the same process is done here also. 0.3, the code word respective code word is 0 and 1. 0.2, the respective code word is see here how the transversal is occurred. 0 1 1, and the 0.15, the respective code word is 0 0 0. We are writing this one only. And 0.15, the respective code word is 0 0 1. The 0.10 0.10 gives rise to 0.2, where the traversal is occurred through this. The respective code word is 0 1 0. 1 0 1 0 is same, and we are assigning 0 and 1 here. Same process is done for this one also, as the 0.3 gives rise to 0 and 1. 0.211, 0.15 means 0 0 0, 0.15 means 0 0 1, and 0.10 code word is here. The travels are done here. So the 101, and the here the summation 0.1 comes from this one. So 0.05, 0.05, which will be the respective code wise 100, 1000, and we are also assigning 0 and 1. From this code word, we came to know the how the Huffman coding is works, and the which one is tell in the first introduction that if, it assigns shorter code word for the larger frequencies and the longer code word for lower frequencies. It is same. Let us know the 0.3. 0.3 is the highest frequency and the code word is low. The 0.05 is the lowest frequency, so the assigned code word is high. By this, we can conclude, and we are writing the, as we know the efficiency formula, H is equals to P1 Pi log 2 log base 2 1 by Pi. By this, we can write the efficiency, and we know the efficiency formula 1 by H. 1 by H will give rise to the efficiency formula. This is basic about the Huffman coding and how the Huffman coding works. Let us know the applications of the Huffman coding. Applications of the Huffman coding is works like file compression, image compression, video compression, audio compression, and database compression. These are the basic compression techniques which are used Huffman coding. These compressions uses Huffman coding for the reducing the size. Thank you for giving this wonderful opportunity.